Hello everyone, so this video we will be going through the Set 3 Term 3 Test 1 on light, wave and EM spectrum. So in order to save our classroom time, I will post this video. I will use this video to actually go through with you your common mistakes. So how do I know that you have watched this video? I will be collecting your correction on this paper. So for your correction, right, here are some of the criteria. Okay, if you get a calculation type of question wrong, I want you to do the whole part, just that part that you get wrong. For example, if the question 5, you have 5A, 5B, 5C, and you only got part B wrong, so you redo 5 part B. Okay, A and C, you can keep it that way. So when you are doing the correction for calculation question, I want you to redo the entire presentation for that particular part. You can do it on the empty space nearby if you have them, or if you do not have an empty space, please do it on a fresh piece of A4 paper and then you just staple it at the back. Now for questions that have diagrams, like you are asked to draw ray diagram for a lens, or if you are answering a structure question, I do not want you to just merely copy down the answer key. I want you to edit your existing answer, that means your answer. I want you to edit your answer by either adding in the missing keyword, or if there is wrong concept involved, remove them by striking through the words with a different color pen. Okay, I repeat, I want pen. If really you are running out of pen, I can accept pencil, but try your best to have at least a green pen with you, so that when you do correction, you can differentiate which are the correction, which are your existing answers, so that during revision you can spot them quickly. Okay, so this correction I will update you when it is due. Normally I will give you like maybe 2 or 3 days. Yeah, so that is my requirement for your correction. If your correction is not up to standard, I will ask you to redo your correction. So I just want to be upfront and clear about my expectation. Can? Okay, so let's carry on. Okay, your first question is the law of reflection. Most of you are able to actually give me a good definition for part 1. Unfortunately for your part 2, some common error is that instead of saying that it is the ray and the normal that are on the same plane, you decided to actually call this the angle of reflection and the angle of incident on the same plane. So angles cannot be on the same plane. They have, it's angle. So please remember, for law number 2, it is about the rays and the normal. And many of you have actually forgotten to actually mention that we are talking about the point of incident. Okay, so a lot of you leave out this point, and as a result, you got half a mark deducted. Now please bear in mind that in O level, when the paper is upon 120 marks, they will not be giving you half marks that linearly. So because in this paper it is based on 30 marks, the teachers feel that by taking away 1 mark just for forgetting point of incident is a bit too heavy-handed, so we decided to give you the half mark. So when you are memorizing laws, very often I would say that the law is already as concise as they can. So the word that they choose to include in the law serve a purpose. So if you are not sure, please ask me, and then I will explain to you why those words are required. Okay, if not, almost all the time, you will need to memorize it word for word. The best way is you understand the law, why these words are included, and then it will make memorization much more easier. Okay, for question 2, most of you are able to draw me a good diagram which is symmetrical. What do I mean by symmetrical? It means that when you have the incident angle and the reflected angle, it will be best in your diagram that you include an indicator saying that you are aware that these 2 angles are normal. So even if, let's say, the marker has a very high standard of symmetry, they will not fault you because you have shown evidence that you know that these 2 angles should be the same. So similarly for here, you should be showing me that these 2 angles is the same. It will be the best. Of course, you should also include arrows to show how the ray is moving from which direction to which direction. Okay, so as I was saying, the angle of incidence and the angle of reflection is always measured from the normal, which is pink here. So that's why I mark it up. So a lot of you didn't, or I would say many of you have forgotten that this angle of reflection is actually referring to, maybe I draw bigger, is actually referring to this angle measured from the normal. So how do you get this angle? You need to do your geometry. So if down here, let me erase the colors so that you can see clearly. Okay, so this is a fresh piece, right? So basically what I need to do is that I need to find out what is the angle here, because this is the angle of reflection. So you have to start somewhere. One way to start is that you can start from here. So you know that on that side is 20 degree and then it is symmetrical. So it means that this angle over here, it is your 20 degrees, right? So what you have here is that you can see that you have this green triangle that I'm highlighting. So this green triangle looks something like this. And you have already deduced that, okay, this guy over here is 20. The question actually informed you that down here is 135. So what you can do is that you can work out this angle. This angle, after you work out, I think it is at 25 degree. So meaning that down here, over here, this is your 25 degree. So once you know that this is 25 degree and you know this is the normal, this one here is the normal, you can actually find out this guy over here. So this guy over here would be your 90 minus 25. So once you have found this, which is for this, and you know that angle of incidence has to be the same as your angle of reflection, actually this is also this. So as a result, you get your answer 65 over here. Okay, so if you got this question wrong, I would expect you to redo this whole part, showing me in detail what are the steps. You can label it, you can label the angle, you can call this angle, for example, you can call this angle O, and then after that you can call this angle R, things like that to help you in your presentation. So I will be looking out for all these markers and see whether you can present your thoughts mathematically and clearly. Okay, for the next part, question 3. Okay, whenever you are asked to state what it means, right? Basically, your definition, the first line of your definition is always to define what is this. So that's why you need to start with it is a what. Understand? It is very seldom that you say something like speed of light blah 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 over speed of light in blah blah blah. Actually, during the marking, I wanted to actually give all those that who just say refractive index is speed of da 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 divided by da da da. This is not what it means. Okay, that is just a verbal mathematic expression. I wanted to give you guys 0, but because the other teachers in the other 2 class wanted to be lenient and wanted to encourage you to do better, so we gave you half a mark. So in the end of year, if it is a definition kind of question, and if it is not to standard, I will just set the answer key as it's either 1 or 0. I make this very clear to the other 2 teachers that, okay, fine, this is the first test. We will give you the benefit of the doubt. We will mark it linearly. But for end of year, please mark my word here and now that it is either full mark, 1 mark or 2 mark or 0. Okay, so it's either you get it or you don't get it because it's about effort. Okay, if you make the effort to memorize, okay, you got it. Okay, if not, then so be it. So your definition will always consist of 2 parts. First, you need to tell me it is a what. What is this? Then followed by a short, concise description of what it means. So for your refractive index, if you remember the formula is C over V. This is not a division. This guy is a ratio. C is to V. So you must tell me that this refractive index, it is a ratio. So this is what I mean by classifying it to what it is. Then follow up with a short description of what it is. Okay? So always definition follow this format. Okay, then after that, I'm quite disappointed because I give you the revision and I reminded you millions of times. When you are using your Snell's law, very good, many of you stated the starting formula, which I have awarded you the mark. But when you are dealing with the angles, you have to measure the angle from the normal. Where is the normal? This is the normal. So when you are dealing with the angles, we are actually dealing with this guy, this angle, and this angle over here. So theta is always measured from normal. What is theta? Theta is this guy over here. This symbol is called theta. So that's why down here it is not 35, it is 90 minus 35. And this question, we want to see how many of you are actually reading the question. That's why we have this. So if it is not stated clearly in the question, what is the precision? 2SF. But if the question wants 3SF, give it to it, 2SF. Okay, so for all your answer in theory paper, this is what we call a theory paper, all answers 2SF. Yeah. So let's carry on again. A critical angle. Many of you actually doesn't deserve the full mark, but the teachers decided to go lenient on you. So again, firstly, it will tell you what it is. So it is an angle of incidence. Yeah, it is that. Then after that, you give a brief description of what it is. In your textbook, they actually describe the medium in terms of optical density. To be frank, so far I have not seen anything being measured by optical density. There's no unit for it. So better to upgrade your answer to a secondary school level, which is to involve the refractive index. So it's from a medium of high index to a medium of low index, and that in the low index, the angle of refraction is 90 degrees. Please take note, do not use simples like that. You have to spell it out, angle. Okay? Then for 4B, I'm surprised that many of you didn't get it because again, it is in the revision worksheet. What we want you to do is to compare the angle of incidence with the critical angle. So where do I get this critical angle? Okay, in O-level, they are very tricky. Sometimes they will embed key information at the starting part, the starting part of the context. So down here, we have actually stated the critical angle at the top. Okay, so whenever you have to predict how the light actually behaves, it's always comparing incident angle to the critical angle. That's why incident angle is so important. So the first part whereby the incident angle is 0, this one is in your revision worksheet. Okay, and you will notice that if angle I is 0, you will get no refraction, so you go straight. Then after that, you look at the second ray, which is this ray, and you can see that the angle I is 30. So what does it mean? You have to compare the angle I here, which is 30, with 49. So 30 is less than 49. It means that the ray will escape. So it will refract into this medium. So how will it refract? Will it bend away from the normal or towards the normal? So why do I draw this dotted line? Is to help you gauge which portion will it be. The new ray that is in the air can occupy either this region or this region, depending on the refractive index, whether the light is slowing down or whether the light is speeding up. So since it is entering into air with a index of 1, it will speed up. So when it speed up, this is called the normal, and when we say that the light speed up, what will happen is that the light will bend away from the normal. So this is away from the normal, right? This dotted line here in black, this dotted line is your original path, right? If the path didn't change, it follows this path, right? So what happened is that it bends away from the normal. So compared to the original, can you see that the new ray is away from the normal? So this is what we mean by when the ray speed up, it bend away from the normal. That is what it means. Okay. Now in the last ray, which is this green one that I'm drawing now, you can see that the angle of incidence is larger than the critical angle. Now when this happens, a special phenomenon called total internal reflection happen, and it will bend back into the medium. Okay, and because it is total internal reflection, it will follow the law of reflection, meaning that this angle here will be 60. Okay, so you are actually expected to quote this thing over here, but like again, we are marking it very lenient. We didn't push the marking standard to like set 4 standard yet. So please remember to have all these things and include it in your correction, even if you got full mark, because in set 4 you are going to use all this material as your revision materials. Okay, question 5, most of you did correctly, so I'm going very quickly on that. So first you need to know ... In order to form an image, definitely there will be one ray correcting, and since this ray didn't bend, it means that your optical center is here. So this means that your lens has to be here, so draw your lens symbol correctly with double arrows. After that, actually the question requires you to label it L, so label it L for it. The next ray that you usually draw is a ray that is parallel to the principal axis. This is called the principal axis. So once you do that, you know that from this point you should bend towards the focal point, but focal point not given. So what do you know? You know that the ray will eventually reach your image. So let it reach the image. So it means that this is your focal point. So the question actually doesn't want the focal point, it wants the focal length. So what is the focal length? Please present it properly, dot it out, and let me know that, oh, my focal length is from here to here, this is my F. Label it F as well. Yeah. Then after that, you need to show state and application. Can you see that this object is being enlarged? Yeah. So imagine you are using a camera, you take a photo. Does the photo appears 1:1? No, right? The photo actually shrink, the camera actually shrink the image into maybe a 4R size, right? So camera cannot be a correct answer. Some of you say photocopier. Photocopier, I take an A4, photocopy, give me a A3, A5 or A4. A4, right? So same size. So if the image is of the same size, application is photocopier. If the image shrinks, it's like your camera. You take a photo of your friend, the image doesn't appear 175 cm, right? It shrink to your handphone screen. So shrinking of image, camera. Okay, so in this case is being enlarged. Where can you find an enlarged image? Just look at your classroom, the projector, right? The projector, right? The screen on my iPad suddenly being blown into a very huge size so that everyone in the room can read. So down here, one of the most easy question is your projector. Can? Okay, down here, wavefront, I have to repeat many times. Your wavefront is basically a simplified diagram of a 3D wave. So this is the 3D wave. What happened is that scientists just link up all the crests together to form this line, which is called wavefront. So meaning that your wave length is from peak to peak. So basically this is one wavelength, right? So therefore this is 1 wave, 2 wave, 3 wave, 4 wave, 5 wave. You have 5 wave over here. Once you know that, then you need to be careful when you are calculating frequency. Frequency means that how many waves are there in 1 second. So now from the diagram, you know that in 6 seconds, you will get 5 waves. So you have this. You want to know the frequency, which is how many waves in 1 second. So you divide by 6 over here, you get this. So it is a ratio, so you divide by 6 as well. So that's how you get frequency equals to 0.83. Okay, this part here I will spend more time because a number of you got it wrong. So you have to state the direction of X at the instant. So a lot of you, I will not say a lot of you, some of you say that, oh, it will be perpendicular. Perpendicular means that perpendicular to what? So some of you say that, oh, it is perpendicular to the direction of propagation. Okay, fine enough. Perpendicular to the direction of propagation, it means this. But the question is asking at the instant. So you are saying at that instant, it is both going up and both going down? Cannot be, right? It is not like you are studying electrons. Yeah. So in this case, when it says at the instance, you need to be very specific. Is it up or is it down? Right? So how to decide? So what you are seeing here on the figure 7.1 is basically a snapshot of what is happening to the wave. So for example, we call this t equals to 0. Right? In order to actually decide whether this guy X is going up or down, we need to fast forward. We need to fast forward time and we need to see what is the next position X will be at. Then we can decide at this very instance whether it is going up or going down. So how to do that? So this is, the blue one is currently t equals to 0. Just imagine that this t equals to 0 we let time move. So the direction of propagation is like that, right? So it will move like this, am I right? It will move like that and throughout. So what we will do is that from here, we will just move a little bit so that we know in the next time frame, where will the wave be. So now you can see the black wave, the black color line is t equals to 0. The blue color line is when it is t equals to 0 plus a bit. So I want you to zoom into here. This is how your x will move. It will move perpendicular, right? So it's either moving up or down. So you can see that the new position of x is actually here. So if you compare this black dot with this red dot, you can see that in order to reach the position of the red dot, the black dot has to go up. So because of that, we know that at t equals to 0, the dot has to go up, because in the next time frame, it will appear on top. So in order to go on top, I have to go up, right? It's like saying that at this very instance, you are at where you are. And then I am able to predict that, oh, you are going to, in the next time frame, you will be at like, you will be sticking to the ceiling. Then I ask you, so currently now you're going up or down? Since I know that in the next time frame you are at the ceiling, then I would know that currently you must be going up, because in the next time frame you are at the ceiling. Okay, you get what I mean? Yep. So that is how it works. Okay, wavelength, most of you got it. The drawing of the graph, I will talk about it later. Okay, part 1, most of you got it also. So let's talk about your part 2, when you are drawing the graph. So when you are sketching the graph, it is very important whenever you are sketching to actually label, okay, all your intersect, your key axis and all that. So in final year exam, I expect this standard. Okay, so far we didn't penalize you if you forget to label it, but in end of year we will. Okay, so half the amplitude, most of you got it, so that's why I already draw it there. Okay, half the original frequency means what? It means initially within 2 seconds I have one wave. Half the original frequency means what? So if I have frequency equals to 1, it means that your period is 1, right? Half the original. If I have half the original 0.5, it means that t equals to 1 over 0.5, it means 2 seconds. So can you see that when your frequency is being halved, your period over here will actually get doubled. So for example, let me give you an even more concrete example. Now what I'm saying is that the period of this graph is 2, right? So period is 2 seconds, right? That means it will give me a frequency of half, because 1 over t. Now based on the change, my frequency is being halved, become 0.25, right? So what is the period? 1 over 0.25. 1 over 0.25 is 4. That means in 4 seconds, I will have one graph, meaning that now one wavelength is here. So therefore, I would expect a graph that looks like this, right? Here will be like that. Or maybe I use blue. So this guy goes like that. Oh, I should be touching. Like that. And then oops, then like that. Yeah, then I have to blanco some of it here. Then this one goes like this, touching, not very good. Yeah, but good enough, I guess. So like that. Yeah, so this is how your new graph will look like. So please, if you got it wrong, do copy down this part and then use a new color pen. We do this on the space given. Okay, for question A, most of you studied. I think you guys can remember. Okay, for part B, many of you got it wrong. Reason is, okay, this is visible light, and this part here are waves with wavelengths that are larger than your visible light. So actually this part on the right down here is actually your infrared, not ultraviolet. Ultraviolet appears here. So in your answer, please make use of words given in the diagram. So if you do not know how to phrase it, most of the energy emitted per second, is emitted as IR, right? This is IR, right? So why is this performing poorly? Oh, because IR is invisible to our sight. Short and simple. So then, what are some possible use of your light bulb? I have cases whereby people say use as ear thermometer. So what? You're going to stick your light bulb in the ear like that. No, right? So you cannot. Anyway, your ear thermometer is a detector of infrared rays, right? So if you are talking about your ear thermometer is a sensor that will actually measure how much IR is given off by your skin. So is your light bulb a sensor that can measure how much IR is given? No, right? So it doesn't work that way. Yeah. Some of you say head thermometer, same thing. Okay, any thermometer is a sensor. It measures things. Light bulb doesn't. Some of you say remote control. No, you have to say the remote control, right? I know that there's a screen and then after that it looks like that with buttons here, right? Down here, this thing is not a light bulb, it's an emitter. Okay, it is different from a light bulb. And what is most importantly is that this kind of question wants you to make use of your data given. So if you look at the data given on this particular light bulb, you can see that this light bulb will give off infrared ray. Mostly it gives up so much. So how do we make use of infrared ray? Well, infrared ray is your thermal radiation, right? So it's to warm things up. Some of you are saying this light bulb is used in microwave oven. Does this light bulb give off microwave? No, right? So it cannot. Okay, some of you also say use this light bulb to cook things because it gives off infrared radiation. Do you know that to cook food, you need to give a lot of heat? Yeah. So imagine if you use that light bulb to cook food, wow, it will cook all the things in the surrounding. So cannot. So what does this light bulb use for? You remember before COVID-19, whereby you go to a buffet, they use this light bulb to actually warm and brighten up the food, right? Yes. So this light bulb, you can use it to warm or to keep your food warm. You can use that, or some of it is basically you just give me a possible application whereby it's to keep things warm, whether you keep your fish warm in the fish tank, or you want to keep your food warm, or you want to keep whatever thing warm because it gives off a lot of infrared. Can? So that's the end of the going through. If you have questions, please let me know. If you have still problems with the marks, let me know as well. Can? So I will look forward to see your correction. So I just repeat questions like that. If you got this wrong, copy the entire thing in a space, in an empty space. If not, on a fresh piece of paper, staple it at the back. If you have problem with sketching, sketch it directly here. If not, copy the question and all that, but it will be time consuming. So I suggest you just sketch out a new one on the diagram itself. If it is on explain kind, do not copy what I have here. You can copy what you have here, but I also want you to edit your own answer. Okay, so you can copy out, but I want you to edit your own answer. Okay, I will see you then. Bye bye.